All right, the last thing that you need to know about here is the Milky Way galaxy and other galaxy types. You've seen this before. This across the sky here is the band of the Milky Way. You can see it on particularly clear nights, and it's blue or whitish and goes across the sky. So the first thing that you need to know is, what is a galaxy? A galaxy is a large collection of gas and dust and stars and whatever's going around those stars. So it could be planets and moons, et cetera, other solar systems, all this within a galaxy. It's interesting, how do we see our galaxy? We can see a lot of it, just like you can look down at the rest of your body from your head because you happen to be on the outside portion. And if you look in this diagram, you can see that the Earth is located out on kind of the edge of our galaxy, so we can look inward and see a lot of the rest of our galaxy. We can compare it to other galaxies, and that's how we know what our galaxy looks like. Our galaxy has a bulge at the center here, and it has this disk area with arms on the outside of it. I'll give you a better look in one of the later slides. Now, there are several types of galaxies. This is Hubble's tuning fork of galaxies. So you can see it is kind of shaped like a tuning fork with these E-type galaxies, which are elliptical galaxies moving into spiral on the top half and spiral on the bottom half, and then this group on the end, which are irregular galaxies. The categorization of galaxies is strictly based on their shape. We'll look at some of the specifics here. There are three categories of spiral galaxies. These are regular spiral galaxies. You can see them in the image here, and basically it has to do with how big the central bulge within those galaxies are and how tightly bound those arms are. Are they tight or are they loose? So you can see with the arrow here that going from left to right, we have looser arms, we have a smaller bulge at the center. And these are listed as SA, SB, and SC. So spiral A, spiral B, and spiral C, going from left to right. So spiral C has the smallest bulge and the loosest arms. The next type is barred spirals, and the only difference between a barred spiral and a regular spiral galaxy is in the center of these, there is this bar shape as opposed to a central bulge. So galaxies that are spiral barred galaxies will have that in the center. And you can see here that we have decreasing size and open arms moving from left to right. And again, this has the same nomenclature, A, B, and C, and SB for spiral barred galaxy. This is a image showing us kind of what our galaxy looks like. You can see this is the central portion of the galaxy here. It was actually recently determined that we are in a spiral bar galaxy. These are names for all of the different arms inside our galaxy, and we happen to be located on the Orion arm. This is our solar system right here of our galaxy. The next type of galaxy is what's called an elliptical galaxy. Elliptical galaxies basically are designated on their shape. So the roundness of it, if it is close to a circular shape, it is an E0, and the farther it moves away from a round shape, the more this number goes up. So they move from circular to elliptical, and there are 8 categories. These are different from the others because obviously you can see in these images they have no spiral arms, they have no disk, they're just a tightly compacted area of many, many stars. One of the things to understand about them is they contain very little cool gas or dust. And if that's the case, then that means they have little star formation and not very many new stars. They're older stars. Now, another type of galaxy is an irregular galaxy, and they have a wide variety of shapes, but no specific shape. You can see these are very, very different. Some of them, This is the Small Magellanic Cloud. This one is visible in the southern hemisphere. It's not one that you and I can see here in North America. This particular one was probably caused by the collision between two galaxies, one here and the remnants of one there, and they spun and threw each other into this weird shape. So a lot of irregular galaxies are the direct result of galaxy collisions. The last type of galaxy is a lenticular galaxy, and they have a disk and a bulge, but no arms, or interstellar gas. So again, these are very old galaxy clusters, not a lot of new star formation if they don't have interstellar gases to form new stars.